Hi guys, so this video is going to be looking at mixed factorization, looking at a couple of questions where you might need various approaches of what has been taught in this chapter so far, and trying to figure out how to deconstruct and reconstruct things through the process. It does require patience, it does require trial and error in some cases, so don't be afraid for those things. Definitely recommend for you to, I guess, time yourself, and hopefully through the tests conditions, you've given yourself enough time as a buffer to proofread your work, to see what else you could do. As the questions and the answers, or the questions might seem a little bit complicated, and the answers may not allude to something so simple and neat. And one of these two examples will kind of demonstrate that. So it comes down to confidence through your working out and making sure that you've applied everything thoroughly, and that you haven't skipped any steps. Okay, so in this case here, what I notice is that we've got x plus 1 and x plus 1. I'm actually going to make that phrase equal y and use y into my substituted expression. So we've got this, which becomes a non-monic expression. And so to approach it non-monic, a times c, which is our 2 times 2, that's 4. And our factors of 4 that add up to our middle term, which is 5, is 4 and 1. So I want to split that 2 into 4y plus y and rewrite everything else in as per usual. We've now introduced 4 terms, and so that term, or that part of the term and that part, we're going to factorize by grouping. And our common factor for the first half is 2y, and y plus 2 is going to be in brackets. Then the second half is going to be y plus 2. We do want the two brackets to be the same. So what we have here now are two brackets that are identical. If they're not identical, then you've, I guess, factorized the two halves incorrectly. So you'd want to backtrack and see where you've actually took a wrong turn. The common brackets is y plus 2, and 2y plus 1 falls into our second set of brackets. So that's how we would factorize that. However, we haven't reintroduced our x plus 1, which is up here. And so we want to make sure that we put that back into our equation. So we've got x plus 1 plus 2 in our first set of brackets. And then we've got two lots of x plus 1 plus 1 in our second brackets. Let's expand that. So we've got 2x plus 2 plus 1 over here, and we've got x plus 3 on the left. So notice that the x plus 3 can't be simplified, but we can simplify that bracket. So what we'll have in the end, if I bring this up here, is x plus 3, and then 2x plus 3 as our two sets of brackets, and that is our factorized form. Now, if you have these two brackets in a different order, say let's say you have 2x plus 3 first and then x plus 3, it doesn't really matter. It's like 2 times 3 is the same as 3 times 2. So this, guys, would be our answer. And let's move on to the next question. Okay, so what we have here are two sets of fractions, and the one's divided by the other. So obviously when you divide fractions, you want to have the reciprocal of the second fraction and turn the division to a times. So I'm going to be doing a couple of processes simultaneously, so you know what's happening here. But firstly, so I'm going to keep the left hand side for now, and it's always handy to rewrite each step clearly, so you know where you're up to and you haven't skipped anything. Sometimes when you're in a rush, you want to skip steps and you forget, or you oversee things that you've done that you should have or you shouldn't have done. It just gets a little bit complicated. So while you are practicing, I really encourage you to write everything down. So with this bottom term, obviously that's going to be on the top once we flipped it. If I factorize it, it's going to be 5 outside of 3d minus 2. Okay. And with this phrase here, when I factorize that, we notice that it has a common factor of 4 for all three terms. There are no powers involved, so it's not a trinomial. So we've got 4 outside of d minus 3 minus 4, not 4, minus 5e. And so that's the second half, flipped and factorized. Hopefully that makes sense. So now we've got two other terms, or two other expressions, that we need to factorize, probably in a little bit more detail. Okay, so I'm going to factorize the top one because that does require a little bit more work. So let's get to that. Okay, this guy's not going to go. That's all right. So we've got d squared plus minus 6d plus 9. I want to actually factorize that part because I automatically see perfect squares. So what we have is d minus 3 all squared as its factorized form. If we rewrite everything, we've got that. Okay. The next thing that I identify is this is DOPS, because here we have a perfect square, here we have another perfect square, and the difference of the two is subtracted. Okay, so that means this factorized form is going to rewrite as d minus 3 minus 5e, and then d minus 3 plus 5e. Hopefully that makes sense. Let me know if you want me to clarify anything, but we got DOPS here. That whole term in brackets is squared, and 25e squared is another squared term. We're going to apply DOPS on those two parts. Okay, so that's the top part factorized. Now the bottom part is going to be, I guess, factorized as a regular trinomial, but non-monic again. So to bring this up here, we have this. So 4 times minus 6 is minus 24. That's our A times C. And our factors of minus 24 that adds up to minus 5 is going to be minus 8 and 3. So we want to rewrite everything and into 4 terms. So we got 4d squared minus 8d plus 3d minus 6. And 4 terms, we want to factorize by grouping. We got 4d minus 2. Let's backtrack on that. So our highest common factor is 4d, and then we want d minus 2. And then plus 3, and then d minus 2 there. Our factorized form is then 4d plus 3, and then d minus 2 at the bottom. Then what we have here is at the bottom, we've got 4d plus 3, and then d minus 2, and we've got 5 3d minus 2 on the top here, at the bottom 4d minus 3 minus 5e. Now we've factorized all four components, both numerators and denominators of each fraction, and we want to look at what we can actually cut out. So what I can see is that we've got the d minus 3 minus 5e. We can cancel that out with that bracket over there. And the sad part of this particular question, because there's so much work involved, there is nothing else that we can actually cancel. So this is where your confidence in factorizing is really important. So I'm going to rewrite everything, and this is your answer. So we got 5 outside of 3d minus 2, d minus 3 plus 5e, all over 4d plus 3 multiplied by d minus 2. That is our answer for this particular question. Hopefully that helps. It is cumbersome. There's a lot of detail, there's a lot of work and a lot of time invested in this one. But if you got other questions, let me know. I'm happy to help you out with those. All right, thanks guys.